Starving children. That'll probably lose the women's rights.
All right. You can put all the other stuff down. Be ready for calculations. We'll do a bunch of problems right here. So this is all about kinematics, and in kinematics, the main focus is on equations of motion. All right. When an object is moving, starting with a certain condition, accelerating or not accelerating, reaching certain final speed, velocities or speeds, covering certain displacements or distances in certain times, you will be able to find some of the other unknown stuff. So that's basically what we do in this chapter. First thing what we did was we went through the definition of acceleration, and then I built up to the equation of equations of motion. So first thing that you should know is all the equations of motion by heart. So Vf is equal to Vi plus At, and x is equal to the average velocity times time, and you have x is equal to Vit plus half At squared, and Vf squared is equal to Vi squared plus 2Ax. These are the equations that you are primarily going to use. And then we went over certain graphs, right? So we went through distance time graphs. What's the slope of a distance time graph? Speed. And then we went through all the different kinds of speeds: average speed, instantaneous speed, all right, constant speed. Displacement versus time. Now another word for displacement is position. See this equation, x is equal to v. This x itself, what the book calls it, is position. They'll say x final is equal to x initial plus Vit plus half At squared. This is how they give that equation. The same equation is given in this fashion. The final position is equal to initial position plus this. Now what I do is I bring this term onto this side. So subtracting xi from both sides, we have this equation. And I call this whole thing as just displacement. We don't really require anything else. We don't want to really confuse and make this equation bigger. And that's why I make it as just x. Now we use the same x, whether it's going the y direction or the x direction. You understand? As long as you are applying it in a certain direction, you don't have to get confused. This x does not have to be only along the x direction. It can be that way. Vertical. So you can have a vertical displacement, you can have a horizontal displacement. So when you're using these equations of motion, you are not going to use it for two directions at the same time. So you're going to use it for one direction at a time. And therefore, the term x should not really get confused with anything else. So some students say like, okay, x is the displacement in the x direction, but what about the y direction? Should I write y? No, you don't have to really write y. You don't have to write capital Y over here just to represent a vertical displacement. X will be fine, as long as we know it is the final position minus initial position. So we don't write this format, we just write that format. And what is displacement? It is the final minus initial, right? It's always the final minus initial, all right? Take care of that. What about a graph, velocity time graph? A velocity time graph, you've seen all those different features of the graph. If a graph is a horizontal line, what does it mean? constant velocity, and if it's accelerating, it's going to be shaped that way, constant acceleration. So how do you find the constant acceleration? The slope. If you find the slope of the line, then you should be able to find the acceleration. And if I ask you how far did this object travel in this particular time, how do you find it? The area under the shape. Now, if I actually complete it like this, then the area of this and this together gives you the total displacement. Area of the whole graph gives you the total displacement. Now, if you flip your pages back to a graph that we drew earlier, I think this was the graph, if I remember it right. It was something like that, and then that, and then that, and that, right? It was a graph like that? And then we were supposed to draw the displacement time graph for the same thing. And our displacement time graph, for the same thing, our displacement time graph went which way? From here? Yeah, it started with a zero slope, right? Yeah. So it went like this, climbing up, and then went like that to a certain slope, and then it held on to that slope for this time because it is a constant velocity from here onwards till here. It went with a constant gradient, and then from here to here, the velocity reduced to zero. So at this point, it reduced to zero, and then from here to here, it turned that way. It turned that way, and from here to here, it was going with a constant velocity till here, and then from here to here, it reduced its constant velocity till to zero. Stop there. Right? That was the graph, right? Now, where is the final position? The final position, the displacement is this, which you can see on the graph, this part, this much. That's a final displacement. Is it a positive displacement or negative displacement? Positive. Why is it positive? Because the total area of the graph is positive. Look at this area of this graph. Look at this area. And look at this area. Which is bigger? This positive one is bigger. So you have a positive area and you have a negative area. The sum of both together still is positive. That's why it came up there. You see it? Why did your graph end up at that position? Is because this area is smaller than this. So your final position has to be up there. Now what if the bottom area was bigger? Then automatically, this thing is going to come down. So let's say, for example, from this point onwards, I'm going to redraw the graph. If, for example, this one went down till here, and then it stayed for a longer time, till here. Now what will happen to the same graph? Till this point, the velocity is changing, increasing downward, and then from this point to this point it's going to stay with a constant velocity, and then from here onwards it is reducing. So where does it finally end up? It ends up below. It ends up below the starting point. And how do you see it from this velocity time graph? The negative area is bigger than the positive area, which means the overall area is negative, which means the overall displacement is, you get it? Okay. Let's work through some questions through which you will get more experience. I'll read out the questions. So, you're driving home from school steadily at 95 kilometers per hour for 130 kilometers. you're driving home at 95 kilometers per hour for 130 kilometers. So 130 kilometers at 95 kilometers per hour. It then begins to rain. It then begins to rain and you slow down to 65 kilometers per hour. So from this point onwards it's raining and so you slow down to 65 kilometers per hour. You arrive home after driving 3 hours and 20 minutes. You arrive home after driving 3 hours and 20 minutes. How far is your home from school? Questions are, how far is your home from school? What was your average speed? So, by doing this, you will touch base on some of the important areas that you need to focus on. So, how far is your school? So, what is this distance? Or what is the displacement? That's the question. You see, after reading a question like this, when you picturize it, you'll now focus only on the picture. You don't have to keep reading the problem. Now you know the problem very clearly. What's going on here? You're driving from school at this speed for this distance. You reached here when it started raining, slowed down to this, and reached home. Totally took 3 hours and 20 minutes. What is that is the question, and what's the average speed is the question. Yeah.
Was the total distance 130 kilometers, or was that only?
No, 130 kilometers is until it started raining. So you're given some information, and the total time is given to you, 3 hours and 20 minutes. Now, you can approach this problem in different ways. Which units you're going to use? You can use completely kilometers and hours and go on, or change it to meters per second, change it to meters per second, change it to meters, and then go on from there. So, and then you have to change all this to seconds. And sometimes kilometers per hour will be okay. Sometimes meters per second, no, I mean, by saying okay, I mean like shorter. Okay? And meters per second sometimes is shorter. So whichever is actually going to really help you out. In this case, you can stay with kilometers per hour and you should be able to do that. So it tells you 95 kilometers per hour, 130. So what is the time here? Can you tell me the time t1 taken for this journey? What do you do? Now remember, this motion is not an accelerated motion. So if there is no acceleration, you know the equations of motion? Those equations of motion is used for accelerated motion. They're all for accelerated motion. If A is 0, what will happen to those equations? Look back into those equations. If A is 0, what will happen to those equations? The first equation says Vf is equal to Vi plus At. At is 0. That means Vf is Vi, of course. If there's no acceleration, Vf and Vi are supposed to be the same. Right? Second equation says x is equal to Vf plus Vi divided by 2 times time. If there's no acceleration, Vf and Vi are supposed to be the same. So when you add two things and divide by 2, it will be the same velocity. So velocity times time is displacement, right? The third equation says x is equal to Vit plus half At squared. The half At squared is gone. So what is the equation left now? X is equal to V times t. There's only one velocity, no initial, no final, just V. So the only equation you're going to use is x is equal to Vt. That's the only equation that can be applied for non-accelerated motion. And so using this, we have the displacement 130 and you have the speed is 95. And so what is time t1? Figure that out. How much is it? How much is this time? No, just get me decimals. 1.37 hours. Now tell me this one in the same manner in decimals. I don't want 3 hours 20 minutes. Instead say in decimals. 3.33333, right? So we can write it as, if you want to write in fractions and all that, but you can write 3.33 hours. That is 3.33 hours, and that is 1.37 hours. So tell me what time it took here. So now we can tell the time. How much is the time there? Subtract 1.9 hours. So now you got the second time and you have the speed. Can you find how far it is? So find out how far it is. So we need x, we have 65, and we have 1.96 as our time. How far? Everyone should be working at this time. How much? $127.4 kilometers. So we know that this is 130 and this is 127.4. What is this thing? Just add them up. Yes, 2. You don't have to really worry about significant figures right now. So, okay, 257 something kilometers. That is the total distance. That's a big distance from school to home. Maybe college, yeah. Yes?
So when you were saying this is a non-acceleration, are you just supposed to assume that because it says it, but technically when the car starts with 0?
Oh, yeah. So that's what they're saying. You're driving from school steadily at 95. Yes, it's certain things you have to understand. You know, when they say steadily at 95, you're ignoring a couple of meters where it actually picks up. So this 95 kilometers per hour is not the initial or final speed, it's the average. So you may start from 0, of course. The average is 95. It is not really any speed at any time. In the same way, the 65 is the average, new average reduced speed. Okay, you understand this problem? Now, what is the average speed? How do you find the average speed? The total distance over the total time. So do this, divide by this. Don't use 320 and all that. You have to do this. So 257 divided by this, it's the average. At any point, if there is any confusion or question, let me know. Good?
77.
Okay. 77 something? Should be alright. Another question, calculate the average speed and average velocity of a complete round trip. You're going from here to here, 200 kilometers with a speed of 80 kilometers per hour. And then there is a lunch break at this point of 2 hours. And then you drive back 200 kilometers at 60 kilometers per hour. What's the average speed? What's the average velocity? So this you should be able to do now without much of an issue. Okay? 80 kilometers per hour, going 200 kilometers. So you should find out the time. What time is it here? What time? How many? 2.5 hours. How much time is this one? How much? 3.33 hours. And 2 hours over here. So what's the total time? So 2.5 hours over here, 2 hours there, 3.33 hours return. So the total distance, how much is the total distance? 400 divided by the, how much is 7? And that should get you the answer. You get it? What's the average velocity? 0. The average velocity is 0. Good. Now let's move on to accelerated motion. A light plane must reach a speed of 33 meters per second for takeoff. How long a runway is needed for an acceleration of 3 meters per second square? A light plane must reach a speed of 33 meters per second for takeoff. How long is the runway needed if a constant acceleration of 3 meters per second square is applied? So that's a runway, that's a plane. It needs to take off. Initial velocity is, final velocity while takeoff is 33 meters per second. Let's say 33. 33 meters per second. And this is what is asked. And they gave you the acceleration is 3 meters per second squared. What equation do you think is going to be applied? Which equation will be applied here?
B.
What's missing? The one without time. The one without time. So pick up that equation without time. And then Vf squared is 33 squared is equal to 0 plus 2 times 3 times x. So find out x. How many meters it is? How much? 181 meters. That's a light aircraft. 182. Since it's a light aircraft, 182 is enough for it to pick up and go. Like it's from almost from here to Shelbyville Road, or a little more. So if the light plane goes from here to there, it should be ready to go. Okay. Got? Next question. A car slows down uniformly from a speed of 21 meters per second to rest in 6 seconds. How far did it travel in that time? A car slows down uniformly from 21 meters per second to rest in 6 seconds. From 21 meters per second, which is initial, to final of 0 in time of 6 seconds. Question is how far? Now, you look at the variables that are there and you see which variable is missing and then pick the correct equation according to this. Which equation can be applied here? The one which does not have acceleration. Which equation is that? X is equal to Vf plus Vi divided by 2 times time. So Vf is 0. 0 plus 21 divided by 2 times 6. How many meters? How much? 60? 63 meters. a baseball is hit nearly straight up into the air with a speed of 22 meters per second, how high does it go? A baseball is hit straight up at 22 meters per second. So you're hitting the baseball 22 meters per second straight up. How high does it go before it turns back? Where are the piece of data? What information do you have here?
Acceleration.
Acceleration, how much?
Negative 9.8.
Negative 9.8 meters per second square. What else do you know? VI is 22 meters per second. What else do you know?
Displacement 0.
The question is, how high does it go? VF is 0. Yes. When it says how high does it go, your starting point is here and finishing point is at the topmost point. That's where you finish the problem. You don't want to worry about when is it going to come back and all that. So VF is 0. And the question is asking you, how high does it go? Okay.
VF squared.
So the time is not there. So VF square is equal to VI square plus 2AX. That's how you pick the right equation. Something that doesn't involve time. So VF square 0 is equal to 22 squared minus 19.6x. So x is equal to 22 square over 19.6. And that's your answer. 24.7 meters. And the next part of the question says, how long is it in the air? How long is the how long is the baseball in the air? I know I said baseball. How long is the baseball in the air? So now we have to start from here and go all the way back again here, because that's the time it's going to stay in the air. So we have to look at the data once again. You're looking for fresh data and fresh equation. Initial velocity is 22. Acceleration you know. What else? How much? 0. And the question is asking for time. So now plug it in. Now these things should be, if it's a multiple choice question, it should not take more than a minute. You should just work it out so quickly. So once you practice these things multiple times, your speed will improve. Yes. And don't make mistakes on your calculator. The equation is x is equal to VIT plus half AT square. 0 equal to VIT, 22t minus 4.9 t squared. See this? Half A is always going to be negative 4.9. And what you do next is 4.9 t squared is equal to 22t. Divide both sides by t, you get t is equal to 22 over 4.9, and the answer is 4.48. Time 4.48 meters, 4.48 seconds. It stays in the air. What if you hit the same baseball standing on the moon? Acceleration due to gravity, let's say, is 1.5. If the acceleration due to gravity is 1.5 on the moon, then how long will it take? So what do you do? If the acceleration due to gravity is 1.5 on the moon, what do you write here? Is it okay? No. Yeah, you should understand, even if it's the moon, still it is directed that way. Okay? So negative 1.5, then you apply it. So it will be 22t minus half of that, 0.75 t squared, and then work it out. Okay? Get it? Another question. A ball player catches a ball 3 seconds after throwing it vertically upward. With what speed did he throw? A ball player catches the ball 3 seconds after it was thrown vertically up. A ball player, after throwing a ball up, catches it after 3 seconds. How fast did he throw it? So the question is asking for that. So initial velocity, question. Acceleration, minus 9.8, hoping he's still on the earth. And then what else? Displacement is 0. And time is 3 seconds. So again, use the same equation. X is equal to VIT plus half AT squared. So 0 equal to VI times 3 minus 4.9 times 3 squared. So 3 VI is equal to 3 squared, 4.9. Okay? Is that the right time? Okay. Alright, an helicopter is ascending vertically with a speed of 5.2 meters per second. An helicopter is ascending vertically up at 5.2 meters per second. At a height of 125 meters above the earth, a package is dropped from a window. So that's the ground. At a height of 125 meters, at a height of 125 meters, a package is dropped from the helicopter. So a package is dropped from the window, and the helicopter was moving up at 5.2 meters per second when this happened. How much time does it take for the package to reach the ground? How much time does it take for the package to reach the ground? So, what do you do? Yes. Yeah, tell me.
Okay, so when you release the package initially, it has an initial velocity.
Yes, it has an initial velocity of
5.2.
5.2 meters per second. Yes, the package was still moving with the helicopter when it was dropped. So it is dropped with reference to the helicopter, but with reference to the ground, it is still moving up. So that's what we need to take. Acceleration is negative 9.8. What is displacement? Negative 125. Now those things have to be taken care of. Negative 125. If you don't realize that is going down overall. So what exactly is happening to the package? The package starts from there and goes up momentarily and then comes down. So the package starts like this and goes like that, turns around and comes back. And the helicopter will find its way off. So what is the question? The question is asking for what time it is. Yes?
But what about like the force of the rotors pushing down?
We ignored that part of it. Yeah, we ignored that part because yes, the rotors are actually pushing the air down, so therefore it can also kind of push the package downward, which means the package can suffer more deceleration. Yes, good point though.
Why is VF not in here? Could you put VF equals 0?
VF is never zero. VF is the speed with which it crashes on the ground.
Oh,
We'll find it out too. Yeah, we'll find out that one later. What is the time t? So the equation of motion you're going to use is x equal to VIT plus half AT squared. Negative 125 is equal to 5.2 times t minus 4.9 t squared. And then you frame this into a quadratic format. So 4.9 t squared minus 5.2 t minus 125 equal to 0. You should know how to work this quadratic format. And then find the t. Plus or minus root of b squared, all that stuff. So minus b, so 5.2 plus or minus root of b squared minus 4ac, so it becomes plus 4ac. What is it, 244? Is it okay? Divided by 2a. And then you get 2 times probably. You just have to knock off the negative time and take the positive time. You understand this?
Take the positive time.
Yeah. Yes, what do you have?
do you want us to keep? Oh, okay. No, 5.6.
How much?
5.6 seconds.
5.6.
5.6 seconds. Did you get the other one as negative?
That's negative 4.
So forget it. Yes, 5.6 seconds is what it takes all together. Now, if the question was actually going to ask you how fast it's going to hit the ground, then you don't look at this procedure at all. The question is asking for what is VF, so you go by that approach then. The last equation, VF square equal to VI square plus 2AX, and then you'll find the final velocity. How do you find the final velocity here?
VF squared.
Yes, so we need not time but final velocity. So you just go by Vf square is equal to Vi square plus 2Ax. Vf square is equal to 5.2 square minus 19.6 times negative 125. So you get Vf square. That will be equal to 5.2 square plus the product of these two. Same thing. So Vf is equal to square root of that number. What do you have?
Uh, 49.7.
49.7 meters per second, but you know there's a positive and negative. When you take square root of a number, you have 2 and says plus 49.7 and minus 49.7, which is going to be taken? The minus, because it's on its way down. Because it's pointing downward, that has to be negative. Get it? A ball, another question. A ball is thrown down at 20 meters per second. A ball is thrown down at 20 meters per second from the top of a building. So the building, 100 meters tall, and a ball is thrown down at 20 meters per second. Find how long it takes to reach the ground. I'll give you some time to work it out. Find the speed of landing. And find, okay, do these two. Find the time of landing and find the speed of landing.
What was the
Oh, 20, 20. A ball is thrown down at 20 meters per second from, yes.
if you're throwing it down, would it be negative 20?
Yes. Those things you should take it, you know. Those are the things that you should take care of. No one is going to say that it's going to be negative. They'll say, thrown down. So what you have to do now is take your VI. What is VI? Negative 20. Remember that part of it. And then displacement. What is the displacement? Negative 100. And acceleration is negative 9.8. All negatives. And the question is, what is the time? Yes?
When will acceleration be popped out?
Never. I mean, due to gravity? Never. If it is something like a rocket, then acceleration can be positive. Okay, if a rocket is going up like that, accelerating, yeah, you can have an acceleration upward. But if something in free fall is going to be downward, negative. Because we are taking the convention upward, anything upward is positive, anything downward is negative, that's why. So apply the equations. So negative 100 equals negative 20t minus 4.9t squared. And then frame it into a quadratic equation and then just work it out. The same way as you've done the previous ones. Do you get it? And you know how to find the speed, the final, when it says speed of landing, you don't have to worry about the negative sign. Speed is only the number. If I say velocity, then think about the negative signs. But otherwise you don't have to worry about the negative sign. You can do it? Good. Now I'm going to flip this question a little different. Now this time it is thrown up. 20 meters per second.
We're not going over the answer.
I'm not going over. This is the same thing as what we did last time. So just, it's a repeat. Quadratic equation, solve it and find it. Now this one. You're throwing something at 20 meters per second from the same building. Question is, what's the total distance traveled by the object? Find the total distance traveled.
You're throwing it up.
Yes, I'm throwing it up. Find total distance traveled. What do you do?
You find it where it goes back to where you landed and then add.
Yeah. So what you have to do now here is you have to you have to see what's going to happen. Okay, it's climbing up. It reached the topmost point. So it has already covered some distance. Then it is going to fall all the way down here. So it's going to cover some distance. You have to add those two distances. So what do you do first? find out that distance. So let's find out the height reached. So that's what you do. Find the height reached first. How do you find the height reached? Initial velocity is 20. Acceleration is? Displacement is what? What else do you know? Final velocity, 0. So you can find out the displacement, which is this. Once you have that, what do you do next?
Undisplaced going up.
Now you're setting up a new problem where something is dropped from here and it travels all the way down here. So you find the time taken for that. Not time, displacement. Oh no, you already got displacement.
Can't you find the displacement, or don't you know the displacement is 0 if you do the first part?
Up from here to here, yes, 0. Displacement is 0, but my question is distance.
Oh.
If it is displacement, it's going to be negative 100. There's nothing else there. But the question is, what is the distance traveled? So what do you do? Find the distance here. What do you get here in this one?
20.2.
How much?
20.2.
20.2. Is it? So 20.2 meters it went up. It has to come back another 20.2, so 40.4. And then another 100. So 140.4. The total distance traveled. You get it? Yeah, with this much background information, you should find yourself going well.
Whoa.
I don't know, somebody said 20.2, that's why I wrote it down.
I do get that.
Okay. Vf square is equal to Vi square plus 2Ax. So Vf square, 0, equal to 20 square minus 19.6x. Yeah, it is around that one. So x is equal to 20 square, which is 400 over 19.6.
It's 20.4.
20.4?
Go to hell.